I've started with this and thought to do it in Romanian, but as we speak in English, I'll do that. It's easier for me, actually. So I've done this in the airplane. I just arrived, so excuse the presentation. It will not be so pretty. I will speak more than show. And what I want to tell you is about the digital factory and the fact that I started more than 15 years in the different domain. I started from in automation and the shop floor. We call it OT, Operation Technologies. And now I'm somewhere in the middle of OT and IT, and this is an IT conference, but we will speak about the factory and the fact that these two worlds are not so spread apart right now. And a bit of history, just that we know what we speak about. A long time ago, we invented, we had the first revolution in industry where we had steam and water, and we put some things in motion, and we milled corn or something like that. So that was the first revolution. The second one was when we got in contact with electricity, we had developed motors, and we could have more speed, more production. So that's how the first production system started. Actually, the first line, production line, started from the food industry, where they cut pigs, for example, and that's how the first automotive company seen how they disassemble a carcass, a pig carcass, and they said, okay, we can disassemble that, but we can do a car with the same principle, just put everything together on a continuous line. Afterwards, we invented the computer. We had the transistor when we got the computer. And that changed things and changed the speed, how everything evolved. And we could automate stuff. We had controllers, we call it PLCs, so it's programmable logical controllers. That's what I've done. It's so different than, it's a low level of programming, for example. And we can automate everything. We had the speed, we had a lot of production. So that's what the third industrial revolution, and that's where a lot of manufacturing in the world there still are. I think 80%, maybe more, 90% there still are in the third revolution. And where we are right now, what we are doing is we are in the fourth revolution of industry, where internet entered industry, so met industry, and that's where OT and IT meet. So now we have connectivity. We have devices that were like on an island. You didn't have any access. There was a gap, an air gap in between. But now we can connect everything. It's for example, sensors are very cheap at the moment. We can put sensor everywhere. We speak a lot about IoT. You've seen before that we can easily automate a door from a garage system, and you just send an SMS and everything opens or closes and so on. So now it's easy and it's cheap. And that changes things not only in home automation, but also in industry. And now I will tell you more about how it looks right now and where we want to go with this. So, for example, in a normal plant, we have these layers. First layer is the shop floor, is the operation, where PLCs, controllers, machine, everything, it's down there and does something. There's the HMI, where the operator puts some numbers in and it can control something. Second layer was the SCADA system, where we can oversee the entire factory. Or, for example, if you speak about the water treatment plant, you can have a SCADA system that can see all the water treatment plants in for example, Mureș, from one control room somewhere in the city center. Afterwards, we have the MES system. That's where the process is controlled, where we have the orders, where we know what machinery is available or not, and how we send something to be produced. The next layer is ERP, or Enterprise Resource Planning. And there's where the orders come in, where we know what stock we have, and that's the accounting level and so on. Next one is the cloud, if you want to send data in the cloud and so on. And the model that is right now implemented and as I said, more than 80% in the world, is this model, because this was designed a while ago, before the fourth revolution, and everybody stick with this. And for this, if we want to move data from the shop floor up in the cloud, you have to pass all these layers. It works, but this is not the right way. So we need something else. We need to do something else with it. So for that, it's in Romanian because I said I made it in Romanian. Anyway, a shop floor like this, and what we want to achieve is we want to have a paperless shop floor. So we don't want to have papers in between these layers. Because, for example, in a lot of factories, we don't have this there is no connection in between these two layers. And someone from here or from ERP sends an email, another guy prints that email, brings it to the SCADA system or to the shop floor layer, shows it, okay, you have to produce 100 pieces, 1,000 pieces of this product, and the guy does it. But that's paper. It can be lost, it can be damaged. You can read something, yeah, you can read it wrong, and you can have lost products or damaged production. Anyway, what are the values of this factory, the digital factory? We will have a single source of truth. So now, for example, we will have different sources, different, because I have to edit some variables here. I will do it once again here and once again here. So I can do mistakes. And with this model, I will definitely have mistakes. So another value will be the connection between these layers. Real-time data. Now, for example, if we are looking on a report, that report is from the previous day, and it's generated at 12 o'clock in the evening, and the manager or the production manager will look at the report in the morning when it reaches the office. But the damage is already done, and until he will take some action, and you will see another report the day after. So it is not in real time. But in the digital factory, everything will happen live. You will see exactly what is your performance in this moment. Yeah, big data, not that. I cannot. It's hard to do it sometimes because we have a good vocabulary, but sometimes it's fine. So yeah, we heard a lot in IT. We heard a lot. We speak a lot about big data and this kind of buzzwords. That can be that's a thing that for the new digital factory that is very important, because from there you not only can take out reports, but you can see something that you don't have access at the moment in the old model. Yeah, we can develop machine learning. We can have machine learning, and the machines can be automated and can work and can fix by themselves. They can be self-fixed, or they can improve themselves. And everything that I say now and I speak about it, this is not the future. This is happening right now. We are doing this. Predictive maintenance. At the moment, and that 80% that I'm telling you, it's preventive maintenance. So you bring your car to the service when you know that you already done 15,000 kilometers or something. You go into service, they change whatever they think they should change, and yeah, let's hope that nothing breaks. But sometimes it breaks because they didn't change everything that could break. So predictive maintenance, it's different. It sees the state of the machine, and based on how it performs, it will signal if something goes wrong before that damage is done. What is not a digital factory? For example, end-on boards. End-on boards is something that looks like that. It's red, green, yellow. Red means error, green means we'll have an error, and green means okay. SMS notification, email notification, and so many small things. Yeah, I don't know. Anyway, what I wanted to say is that a digital factory is all of that plus more. It's a lot of things. It's a big package. It's something that looks like this. It's an integration on the vertical and on the horizontal. Machines speak to machines. Machines speak to systems, and people and operators don't speak with, they speak with the software, and the software tells them the state. And you've seen that model before, and now it looks like this. This is the old, and now it's something like that. So we have something on the shop floor that's called, we use OPC UA. The OPC UA was designed for this. I will tell you in a bit more about that. And that will provide data on a horizontal layer and also for the vertical layer, through all the system, straight to the system, not through all the other layers. And yeah, we can bring the data in the cloud and so on. Yeah, and now I'll tell you a bit about OPC UA and what is OPC UA and why it's important for this. It's a lot of words, and the thing is that OPC UA means OPC Unified Architecture. We started with OPC DA some time ago, but that was developed using Windows DCOM system, and that was tied on the Windows system, so you can only use it on that platform, and that presented a problem by itself. And a couple of years ago, 2010 or something, 2009, OPC UA was developed, and this changed everything. And when they developed, when the OPC Foundation developed OPC UA as a specification, they followed the Industry 4.0 philosophy that was written in Germany. The German guys that are responsible for industry had a paper about how the fourth revolution should look like. We call it in Germany, or in Europe, Industry 4.0, and in US they call it Smart Factory. Same thing, does the same thing. It is nothing different, but just the wording. And OPC was designed based on that, the specification of Industry 4.0. It's plug and play. It's an information exchange standard. It's multi-platform. Yeah, it's a standard communication within machine. So the machine can communicate to all the modules that it has using OPC UA. It can communicate in between machines, and it can communicate to systems. We use it a lot every day. And this is the universal language for machines, because over the years we have a lot of brands. In my field, we have a lot of brands, Siemens, ABB, Schneider, I can name all of them, but it doesn't matter. And each one of them, they developed their own protocol, and that was a mess. And this cleans up that mess. It's something that looks like this, and you can have data, but not data without the context. So with OPC UA, you can bring the context inside your data, and you can have a structure. You and IT all know that you work with objects, and you can organize an object, and when you look at a value, you see where like in Windows, you see where's the folder from where it came from, so you can really quickly understand from where it came from and what it is. I think I'm running out of time, but yeah. Questions? It's a bit different than maybe than IT, but yeah, I try to. Too much?
Okay. Very nice presentation. I would like to ask.
I'm not so anyway.
I would like to ask if this standard has been already implemented or it's being implemented.
No, it's already. I can say it's not old, but that's what we use right now.
And the follow-up question would be, what's coming next?
Well, it was designed, let's say modular. It was designed for the future. It's not stuck with, when I say cross-platform, that's a very big thing. because it's not stuck with Windows. I don't care what version of Windows I have, because in the past, we were afraid to change something. We were afraid to turn off a computer in a factory, really, because if we turn it off, we never know if it started up again. I've been in a Volkswagen factory some time ago. It was the Easter time, if I remember correctly, and everything should be off, but everything was on. Nobody was in the factory. Imagine a big plant with a bus in the background, because everything was running. And I asked why. We had to work for a machine, and I asked why is this? Because we are afraid. We don't turn off everything. We just leave it as it is, and that's it. Because it happens to me all the time. I turn off when I put in my computer in standby or turn off something like that, and when I have to turn it on again, I have a presentation in 3 minutes. It updates. It takes 15 minutes. Yeah, so that's why. And in industry, that's a problem. And bringing multi-platform in that thing, and you can have Linux, you can have all other system. I don't care if it's Windows 10 or Windows 7 or Windows Server. It works. And that's why I say it's modular, because they can build on top of it. What we are doing right now, and what is the future, is this was, maybe the sandbox is not the right word, but this was designed so we can build standards on top of it. So maybe you heard about injection molding machines, for example, a machine that make you the plastic cups and all of the plastic things. All the guys that produce those, all the vendors, all the OEM that produce those types of machine, they met together and they developed a so-called standard that's called Euromap 88, because there are 63, 77, and 88 is OPC-UA. And that's on top of OPC-UA. And what's that? It's just the way they structure the folders. I say folders, they are called nodes. You get the idea. And they standard that folder is standardized. And for example, for me, if I come with my MES system and I have to read temperature for injection for module 1 or something, I know where it is, because it's in the same place, or anyway, anytime, for each machine that I will use. When it comes to CNC machines, they have empty connect, and so on, packaging, PackML, and so on. So what will happen in the future? They will just build models. So that models can be implemented in OPC-UA, and everything will be faster and easier to implement. That's the thing. Yes?
Hi, so having such a diverse myriad of devices communicating with each other and with different platforms, I was wondering, I'm thinking, okay, I may have Android, I may have Linux or something. There's a lot of issues that might go wrong in such a diverse system in the communication between these. How is this unified architecture built to, how can I say, to manage this kind of mess that could happen?
Well, there is two. Yeah, the thing is that this system it uses a principle called server client. So I will always speak with. I am a server. I will speak with the client who will subscribe to me. So it's sort of a point-to-point, let's say. And that's for the. When you think about it, let's imagine we have the horizontal line, and I'm speaking. There are a couple of machines. Different vendors, different countries, different people design them, but we have OPC-UA. They will speak in between using a client-server system or client-server mode, because that's very high speed and very secure. It's much more secure than the other one I will tell you in a bit. And short thing is that when it comes for my side, from the OT, compared to the IT, for example, IT network in the office network, the big difference is that in the office network we have broadcast. We send something, we just broadcast it to everyone, and every machine, every device has to read all the frames and get if it's for me or it's not for me, it's not for me. And you get a lot of messages and that will, overstress the system. The down part of this, the OT was not designed for that, and there every time when we had communication in between was point to point. So I, as a PLC, send a message to that particular client.
So you had a single point of failure, something like that?
Yeah. But
in a chain of communication.
Exactly, because if that's broken. But that's how this client server works. And the other version of OPC UA, the other implementation, it's using MQTT, for example. If you heard about MQTT, Facebook uses MQTT. Voyager satellite used MQTT. That was what was designed for by IBM in the 90s. Anyway, and now they release it, and everywhere you have IoT, you will hear about MQTT. Now MQTT is implemented inside OPC UA, and when it comes to vertical line from shop floor to the cloud, we use MQTT behind OPC UA, and don't want to go in deeper. But that's a broker. Then I use a broker, a middleman. So broker will connect to a device. Device will publish that data in the broker, and only whoever is subscribed to the broker will get that message. So, yeah.
So it's a publisher-subscriber
Exactly.
architecture.
Yeah, for the vertical line, and for the horizontal, you have the client server. They can be mixed, they can be used, but that's how is the best practice, let's say. But yes, of course, all the time we'll have problems, all the time we'll have challenges, and that's normal. That's how we evolve, and we we make it better. So I cannot say that not everything works perfectly. It will not work. That we already know. That we don't have any more jobs if everything was
so easy.
Yeah.
Thank you.
I guess one more thing to it is that it uses standard data types. Imagine it as the SOAP protocol. It's just not XML based, it's lighter and faster. So that basically it's based on the same data types that every system can interpret.
So it's known protocols or common protocols and common data types, something like that? Okay.
I almost forgot about this. But it's not that. I'm afraid of it. I never used it. I know about it. My colleagues designed it and they make it work. It uses some services in India. Don't ask me. It sometimes fails. So expect to fail, but let's see. The thing is that what's this? It is a buffing machine. It's something from automotive industry, so it's I don't know how to call it in English. I think it's reșapare. I don't know the word in English. Anyway, if you have a second-hand tire, this does something with that. And anyway, it doesn't matter. It's something from the automotive industry. It's something that's used by the manufacturing of tires. It can be anything. It doesn't matter. The idea is that I think the topic of this discussion is smart products. So let's say this is a smart device. It's a device that not only it works and does what it's supposed to be doing, it also should tell you if something's wrong and what is wrong. So it's like a human. I've heard it. The dog cannot tell you what was the problem, but a human maybe can tell. That's why veterinarian it has a tricky job. So the idea is that it uses also augmented reality, and that's the thing that I'm afraid of, because so the machine is running, and maybe you can see it after this presentation, and we can look closer to it if you're interested. Yeah, it's running, and I will now simulate a failure. Trebuie să fim pornit? Trebuie să fim în aplicație ca să meargă sau nu? Ai și
Da.
So I should get notification at some point, but yeah. So let's say I'm in the app. Let's see if it's something that, if not, yeah, you can believe this. I'm not lying. I will simulate a failure. Simulate a failure. Yeah. As I said, I have some colleagues from India that I can blame off, and I'll do that. It should stop at some point.
If you teach the machine to do that, it will be almost human.
That's why I'm afraid of AI. It will blame someone. At some point it stops. Hopefully. Now. Let's wait a couple more seconds.
Is it simulating the process?
Yeah, now it stopped. So yeah, it's something simulating in the background, and it's a machine that works, it gets you some variables, and that failure can be an alarm. If something breaks, a fuse blows, that's an alarm. Okay, and that break, right now it stopped, and I should get something here, eventually. I don't want to spend a lot of time on this, but let's wait. No, the idea is that I get notification, and yeah, probability of failure is very high.
The failure probability of the equipment is beyond the threshold level. Do you wish to see more details on the contributors for this failure?
Yes, but I have to write it down now. As I said, I didn't.
Temperature and oil temperatures are the top contributing parameters for the equipment that is contributing to current state of the failure probability.
As the future, it sucks. Okay.
Wait, you cannot talk to it, you have to write it manually.
I didn't design it.
You did.
Okay.
It's like with the wife, you listen and he talks.
That's why he has a female voice.
Don't go there yet. Okay, it gave me. Yeah, I think the better thing is after we finish, we can play around it. It gave me some parameters. It tells me that something strange is happening and where it's happening. This is the big data part because we analyze everything, we put everything in the cloud, and we can see, okay, that shouldn't be like that, and there's where it should look for. And from this, but as I said, I'll stop it and we'll do it afterwards. We can play around with it. There is another app connected to this with an augmented reality that will place here in front of me, hopefully, the machine. And when I look around, it will have some things to connect to the real machine, and I will see where the problem is. It will point me to the right problem on the machine. As I said, it's hard to show it right now. Let's do it afterwards, and once again, hopefully it works, then not. If not, I will blame the guys in India.